Video is about some previous paper solved question from Federal Board and KPK Board. Calculate delta H of the following reaction. Sodium oxide, it will react with sulfur trioxide and it will produce sodium sulfate. And we will find delta H enthalpy for this reaction. There are some stepwise reactions given along with their enthalpies. So we will solve it. Multiply equation 1 by 4 and equation 2 by 2 and reversing the equation 2. Then according to the Hess law, so first we will multiply equation 1 by 4. So 4 moles of sodium solid, it will react with 4 moles of water and it will produce 4 moles of sodium hydroxide, and half moles are already present and we have multiplied it with 4. So 4 and 1 by 2 moles of H2 hydrogen gas. Now this 4 and 1 by 2, it will cancel out with 4 and it will produce 2. So here the 2 moles are present by multiplying it with 4. Second is equation 2 by 2 and reversing equation 2. So first we will reverse equation 2. Sodium hydroxide and sulfur trioxide, it will move towards the reactant side, and sodium sulfate and water, it will move towards the product side. From the net equation, here SO3 sulfur trioxide is present along with sodium oxide towards the reactant side. So sulfur trioxide here is present at the product side, so we will move it to the reactant side. Also we will multiply it with 2. So 4 moles of 2 are already present. 4 moles of sodium hydroxide, it will combine with 2 moles. Here are 1, so it will multiply with 2 moles of sulfur trioxide. It will produce 2 moles of sodium sulfate and 2 moles of water. And the third equation, it will remain the same. Now we will multiply their enthalpy according to their number. So the equation 1 is multiplied with 4. So the enthalpy is also multiplied with 4. So minus 146 multiplied by 4, it will produce minus 584 kilojoule per mole. Equation 2 is multiplied with 2 and also it is reverse. So with reverse, its sign will be also reverse. Here it is plus and it is minus, and also it is multiplied with 2. So 418 multiplied by 2, it will produce 836 kilojoule per mole, and the third equation will remain the same. Now we will cancel out the same term. 4 sodium, it will cancel out with 4 sodium. 4 H2O, it will cancel out with 2 H2O here and 2 H2O here. 4 sodium hydroxide, it will cancel out with 4 sodium hydroxide, and 2 hydrogen, it will cancel out with 2 hydrogen. Now the net equation is 2 moles of sodium oxide, it will produce 2 moles of sulfur trioxide. It will combine 2 moles of sulfur trioxide and it will produce 2 moles of sodium sulfate. Now summing these 3 enthalpies, we will get minus 1161 kilojoule. Now here 2 moles are present and we will convert it into per mole. So we will divide this whole equation by 2, including the enthalpy. So here it is 1 mole of sodium oxide, it will produce with 1 mole of sulfur trioxide, and it will combine with 1 mole of sulfur trioxide and it will produce 1 mole of sodium sulfate. Here the enthalpy is also divided by 2, so minus 1161 divided by 2, it will produce minus 580.5 kilojoule per mole. So the answer is minus 580.5 kilojoule per mole. What is the limiting reactant if 20 moles of oxygen react with 30 moles of hydrogen according to the following reaction? 2 moles of hydrogen, it will combine with 1 mole of oxygen and it will produce 2 moles of water. So we will solve it. First we will find the stoichiometric mole ratio for hydrogen and water and oxygen and water both. So for hydrogen and water, 2 moles of hydrogen, it will combine, it will produce 2 moles of water. So here the stoichiometric ratio is 2:2. From the question, it is 30 moles of water, so 30 moles of hydrogen. So 30 moles of hydrogen, it will produce how many moles of water? So by cross multiplying it, we will get 30 moles of water that is produced from 30 moles of hydrogen. Similarly, in case of oxygen and water mole ratio, 1 mole of oxygen, it will produce 2 moles of water from the balanced chemical equation. So here is 1:2. In question, 20 moles are given. So 20 moles will produce how many moles of water? So by cross multiplying it and solving it, we will get 40 moles of water. Now the question is about limiting reactant. Limiting reactant is that reactant which will produce least number of moles of product. So by seeing this, 30 moles of water is produced from hydrogen and 40 moles of water is produced from oxygen. Now the hydrogen will produce least number of moles of product. So hydrogen is limiting reactant and oxygen, in this case, it is excess reactant. How many grams of ammonia can be prepared from 77.3 grams of nitrogen and 14.2 grams of hydrogen? The reaction is given as 3 moles of hydrogen. It will combine with 1 mole of nitrogen and it will produce 2 moles of ammonia. So we will solve it in stepwise manner. So first step is the conversion to moles. Here the mass is given 77.3 gram for nitrogen and 14.2 gram for hydrogen. So we will convert these both masses of nitrogen and hydrogen into moles. The formula for the conversion of moles is equal to mole mass divided by molar mass. So moles of hydrogen, 14.2 gram is the mass of hydrogen given in question, divided by 2 is the molar mass of hydrogen. So we will get 7.1 moles for hydrogen. Similarly, in case of nitrogen, 77.3 gram is given in question and 28 gram per mole is the molar mass of nitrogen. By solving it, we will get 2.76 moles of nitrogen. Second step is the finding the mole ratio and limiting reactant. So first we will finding the mole ratio between hydrogen and ammonia. So from the stoichiometric balance equation, 3 moles of hydrogen, it will produce 2 moles of ammonia. So 3:2. Now 7.1 moles of hydrogen, it will produce how many moles of ammonia? By cross multiplying it and solving it, we will get 4.73 moles of ammonia that is produced from hydrogen. Similarly, in case of nitrogen and ammonia, the mole ratio of nitrogen and ammonia is 1 mole of nitrogen, it will produce 2 mole of ammonia. So 1:2, it is from the stoichiometric balance equation, and 2.76 moles of nitrogen, it will produce how many moles of ammonia? So by solving it and cross multiplying it, we will get 5.52 moles of ammonia that is produced from 2.76 moles of nitrogen. Now by looking at the moles 4.73 and 5.52, 4.73 is the limiting reactant because it is the least number of moles of product that is produced by hydrogen. So it is the limiting reactant. Step 3 is the amount of product using the limiting reactant. So we will find the amount of product the moles of ammonia, that is 4.73 moles, that is produced from the limiting reactant, it is converted to the amount, or it is converted to grams. So amount of ammonia formed, it is equal to mole divided by molar mass. Moles is equal to 4.73 moles, that is produced from the limiting reactant, multiplied by 17 is the molar mass of ammonia. We will get 80.41 gram of ammonia that is produced during the reaction. Kc is equal to 0.040 for the system below at 450 degrees C. So here phosphorus pentachloride, it will decompose, it will produce phosphorus trichloride and chlorine gas. Find the Kp at 450 degrees C. Now the formula for Kp and Kc, the conversion is Kp is equal to Kc RT delta N. Its superscript is delta N. Now first we will convert the temperature that is given in degree C into Kelvin. 450 plus 273, we will get 723 Kelvin. Also delta N is equal to the number of moles of product, sum of the number of moles of product minus sum of the number of moles of reactant. If we look at the reaction, here is 1 mole and 1 mole, so 1 plus 1 will produce 2. So the number of moles of product is 2 and the number of mole of reactant is 1, because here is 1 mole. So we will find the value of delta, and that is the number of moles of product minus number of moles of reactant. So number of moles of product is 2 minus 1 is the number of mole of reactant. We will get 1. Putting their values, 0.040 is the Kc value, 0.0821 is the gas constant value, temperature is 723 and delta N value is 1. So we will get 2.73, that is the value of Kp for this reaction.